Why do we anchor tubing? In the 1950s, Arthur Lubinsky detailed the phenomenon of production tubing buckling during the upstroke of the rod pumping system. This buckling of the tubing has a detrimental effect on the production efficiency, as part of the pump stroke is wasted, contracting and stretching the tubing rather than lifting the plunger inside a stationary barrel. Also with this tubing buckling comes increased rod-on tubing and tubing-on casing wear. During the downstroke, the load is held by the pump standing valve at the bottom of the tubing string. As the unit lifts on the upstroke, the load is transferred to the plunger traveling valve and the rod string. This alternating load causes the tubing to stretch during the downstroke and contract during the upstroke. Lubinsky gave us a way to mitigate these negative effects by anchoring the tubing near the bottom of the well to keep the pump and tubing string stationary. The mechanical tension anchor came to be the industry standard for anchoring tubing. But in order to properly set the mechanical anchor, we must first calculate the static and producing load variance, and then correlate that into inches of tubing stretch. This process is fairly complicated and if not followed correctly could result in either over or under stretched tubing. Once the anchor is in the correct spot, the tubing must be turned multiple times in order to activate the slips. This can be problematic in deeper deviated wells because the tubing can torque up against the casing instead of turning at the anchor. Once the slips have fully engaged, the tubing can be stretched to the calculated number of inches in order to account for the fluid load change from static to producing. The goal here is to pull just enough into the tubing that when everything settles out, the tubing tension just above the anchor is slightly positive. We must make sure that slack doesn't deflect the tubing into the rods as gravity pulls it down. But what if there was a better way? Instead of pulling the slack out of the tubing like with a mechanical anchor, the hydraulic anchor allows that slack to automatically compensate downwards. Once the tubing is filled with fluid and there is a slight differential pressure between the tubing and casing, the hydraulic anchor will engage. This setting process happens automatically without any surface manipulation. No turning, stretching, or calculations required. Just run the pump or plunger in the hole and fill the tubing with water or turn the well on. That's it. Your well is now properly anchored. The hydraulic tubing anchor works much like your braking system in your car or truck. The increased load from the fluid filling up the tubing causes a differential pressure between the tubing and casing. This additional tubing pressure is exerted on an internally exposed piston that is attached to an external live slip. As the anchor piston protrudes outward, the live slip presses up against the casing internal diameter. The fixed slips on the opposite side of the anchor have unidirectional teeth that are tapered downward. This taper allows the anchor to slide downward but resist upward movement. As the fluid in the well is pumped up to surface, the fluid level in the casing will slowly lower to the pump. As this fluid lowers in the casing, the pressure inside the tubing increases due to the increased differential pressure. This load on the tubing causes it to stretch downward. The hydraulic anchor accommodates this optimal tubing movement and prevents the tubing from going into compression above the pump, as can be the case with an improperly set mechanical anchor. The Black Gold hydraulic anchor has been significantly upgraded from oil field tolerances to aerospace tolerances. We minimize piston travel and use extremely high-quality military grade O-rings and seal cups to ensure to prevent leaks. The anchor also has a large bypass area which allows gas and fluid to move freely through the annulus. It also has a tapered upper and lower mandrel for easy installation and extraction and mitigates any solid bridging up above the anchor. Once the well is ready to be pulled, the hydraulic anchor is extremely easy to unset and extract. We have retrieved Black Gold hydraulic anchors from even some of the most difficult well bores. Under normal circumstances, just equalize the fluid between the tubing and casing. Your hydraulic anchor is now unset and ready to pull. The Black Gold hydraulic anchor is simplifying the anchoring process and helping your well produce at its most optimal.